Today we're going to be talking about the area of parallelograms and triangles. So to find the area of a parallelogram, the formula is just area equals base times height. Now you'll see that represented as A equals BH. Now B is the base, H is the height. So the height is a line that you're going to see either inside the parallelogram or sometimes outside of it. It's a dotted line, and the side that it drops down to is the base. So here, this dotted line is our height, and then the side that it drops down to is our base. So we take the values for those segments and we multiply them together. So if we look at this next page, this first problem here, we have a height of 2.9, and we see that dotted line drops down to the 6.3. Now, something you do want to keep in mind is this side across from it is also 6.3, because if you remember the properties of a parallelogram, those opposite sides are going to be congruent. So it doesn't really matter which side you look at as your base. But to find the area, we take area equals our base, which is 6.3, times our height, which is that dotted line. It's the distance between those two bases, 2.9. All right, and I'm going to multiply those together, and I'm going to get 18.27. And that's my area of a parallelogram. Now this next one, you will see that the height is drawn outside of the parallelogram. Occasionally you'll see it drawn that way just due to the slant of some of the parallelograms. It's just easier to draw it outside, and that's fine. That makes this 5 right here our height. And then you want to kind of think about what side is this dropping down to. So this is dotted because this is not part of our parallelogram, but this part is. So this is our base. All right, if that were drawn inside the parallelogram, somehow it would touch down on that 5.5. So my area equals, so I have my base, which is 5.5, times my height of 5. And I'm going to multiply that together to get 27.5. All right, I'm going to do that one more time. So again, this 6 is my height. Again, the height is the distance between our bases, really. And again, this has the same value as the one that it's parallel to. They're parallel and congruent. So to find our area here, we take our base times our height. So I have 10 times 6. So I have an area of 60. All right, next we're going to talk about the area of a triangle. You might have seen the formula for this a different way. I like to write it this way for a few different reasons, but how you may have seen it before is area equals 1/2 base times height. Now these formulas really mean the same thing. What I do with this formula, I think it looks a little more concise, and what I would do is I'd take the base times the height, and then I just divide that by 2. That way you're not dealing with the fractions as much. I see that as a point of confusion a lot, so try to keep it straightforward. Now, with your base and height in a triangle, there are kind of 3 different situations you're going to see visually. One is when we have a right triangle. So remember, we have that box in the corner, means a right angle. Our base and our height are the 2 legs that connect together. In these other triangles, you'll see the dotted line either inside or outside the triangle, like we had with the parallelogram. So that height is talking about the distance from a vertex, so one angle, all the way down to another side. And that drops down at a right angle. That means they're perpendicular, the base and the height. So we have our height here, and it connects to this side, which would be our base. And it forms a right angle, so they're perpendicular. And here the same thing, we have our height on the outside, so the line that it would drop down to would be this base here. All right, so again, we're going to calculate the area for each of these triangles. And I tried to give a few different examples of ways you're going to see visually the base and height. So here we have our height from this vertex down at a right angle to the other side to our base. So our height is 2.9 and our base is 7.6. So area equals our base, which is 7.6, times our height, which is 2.9, divided by 2. So it's very similar to the parallelogram formula. We just need to remember to divide by 2 at the end. So I have 7.6 times 2.9. So that's going to give me 22.04, and then I need to remember to divide that by 2. So that'll give me an area for our triangle as 11.02. All right, this next one is the case where we have a right triangle. So our base and our height are the two legs. Those are the things that are connected at a right angle. So it doesn't matter the order that we write these in. If you flip it around, the 6 would look like a base, look like the height, and the 7 could look like a base. And when we multiply, it doesn't matter. So I have area equals my base times height. Again, the order of those two don't matter. Divided by 2. So I have 6 times 7, which is 42, divided by 2, leaving us with an area of 21. And lastly, we have our height on the outside. So that 4.3 is our height. This 7 right here is our base. So I have area equals 7 times 4.3 divided by 2. So I'm going to multiply that 7 times 4.3 first. And that'll give me 30.1. And then I'm going to go ahead and divide that by 2. So I'm going to end up with 15.05. Now, one last thing I want to mention. When you're doing this in the calculator, take this in little steps. So what I'm doing is in this last problem, I multiplied the 7 times 4.3. I hit equals, so I got my 30.1. Then I divided by 2. If you try to do that all at once, your calculator will likely just divide the 4.3, and then you could, depending on how you plug things in, it could get really funky with the way the calculator computes things. So always try to take things in smaller steps when you plug things into the calculator. So 7 times 4.3 equals, and then divide that by 2. All right, and that will give you your area.